Sound, which is 12th chapter in class 9 science. So firstly we understand what is sound. So sound, what is sound? Sound is a form of energy which produces a sensation of hearing in our ears. So what is sound basically? Sound is basically a form of an energy which produce a sensation. It means that a which produce a sensation of hearing. It means that an energy which produce any sensation which we can hear through our ears. The source of sound and its propagation. So what is the source of sound? A source of vibration motion of an object is normally source of sound. It means a vibration or oscillation of an object is a source of sound. So like if we speak anything, the vibration in our throat is occurs, so we can speak, and the vibration is gone from the throat to the air, and the molecules of air become to vibrate, and the sound and the from that vibration of the molecules of air, other person can hear our sound. Characteristics and characteristics of the medium required for the propagation of sound. So what are the characteristics of the medium that is required for the propagation or travel of sound? So the that medium from what the sound will travel, the medium from what the sound will travel, the medium must be elastic, so that the medium particle have the tendency to return back to their original position after the displacement. It means that normally, like the air, the molecules of air, the molecules the molecules of air has a tendency, they are elastic, they have a tendency to return back in their original position. Like that, when the sound is not passing from the molecule are like this. These are the molecule of air, and when the sound is passing from them, they vibrate like this. They vibrate in the direction from in the direction. If the sound is come from this direction, goes in this direction, so the molecules are vibrate like this. So after the vibration pass through them, the way they have the tendency to return back their original position. They have the tendency, after the vibration passing from them, they can they can return back their original position. So before and after the vibration passing through them, they are same, but when the vibration is passing through them, they vibrate like in this, like an pendulum. A pendulum, what is a pendulum? Like a string is, or a thread is like that, ball, and a pendulum is oscillate like, goes in this direction to a height, then goes in this direction to same height. It continues its oscillation. So in like that, the molecules of air also vibrate or oscillate. So, and the second point, the medium must have the inertia so that its particle have the capacity to store the energy. So it means that the medium from which the sound is passed, it has the inertia, and inertia has come from the mass. So indirectly it means that the medium must have some mass. So medium must have some inertia or mass so that its particle have the capacity to store the energy. So if the inertia is in that medium from what the sound is travel, that if the inertia in that object, then it has the capacity to store the energy. What is the in this case? What is the energy? Energy is the what we talk in the definition of sound. This in this line the this energy is used. The frictional resistance of the medium should be negligible to minimize the loss of energy in propagation. So it means that medium that medium from what the medium from what the sound is travel, that medium like the air, the frictional force of air is very less. The frictional it has the frictional force of the air is very less, or we can say negligible. So the if the frictional force in the air is negligible, so it has the energy which is passed through them, or propagation of the energy through them, the loss of energy through them is very less. If the inertia, oh sorry, if the frictional force of that object from what the energy is passes is more or is greater than the then the energy which is passed through it will lose maximum, because the frictional force, if the like this is an object, the energy passes through this object, the frictional force of this object, like we can say P, the frictional force of P is greater or larger. So it so what is frictional force? If anything, like these are two surfaces, there are very hills and rough surface between them. So there is a frictional force, because the rough surface is interlocked each other, and like if the energy is applied in this direction, so the frictional force applies the energy in the opposite direction. So the frictional it means that the frictional force applies the energy in the opposite direction. So if the frictional force applies the energy opposite direction, so the loss of energy is greater. If the frictional force is greater, so the loss of energy is also greater. So type of waves. So the sound is travel in the wave. We all know that the sound is traveling in the waves. What is the type of that waves? There are some types of waves, like firstly mechanical waves. What is a mechanical wave? A mechanical wave is a periodic disturbance. A mechanical wave is a periodic disturbance which require a material medium, which require a material medium for its propagation. On the basis of motion of particle, the the mechanical waves are classified into two parts. So what is a mechanical wave? Mechanical wave is basically a wave which produce a periodic disturbance in any object, and that periodic disturbance require a material, or we can say medium, for the propagation. On the basis of the motion, it means we can say that, like the sound need a medium for the propagation of the energy. So sound is an example of mechanical wave. Sorry, it has two types. The mechanical waves have two types. Firstly, longitudinal waves, and secondly, transverse wave. So firstly we talk about the transverse waves. When the particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave is known as the transversal wave. For example, waves produced in a stretched string. So these waves are like, so the first type of mechanical wave is like that, when a medium, the medium through which the energy is propagate, the propagation of energy is occurred, that medium vibrate in the direction of the in the direction, that direction is perpendicular to the propagation of the waves. Like if the wave is gone in this direction, like we can say the wave is going in the, so the vibration is occur in the perpendicular to the wave. So what is perpendicular? Perpendicular is 90 degree. So the vibration is occur in the 90 degree, like this. So the wave is going this direction, so the vibration in the medium is occur in this direction, like perpendicular to both of the side, perpendicular to the wave. And for example, a stretched string. And second type is longitudinal waves. What are longitudinal waves? When the particles of medium vibrate along the direction of the propagation of waves, then the wave are known as longitudinal wave. For example, sound wave in air. So it means that if the propagation of sound energy in this direction, we can say in this direction, we can say the direction is f, in the f direction. So the particles, or the particles of the medium, like this, we can say the particle of the medium is p. So the particle of p is vibrate along the direction, so the particle of v is also vibrate in this direction, in the f direction. For example, the sound waves in air, Like if the sound waves are flow in this direction, in f direction, the particles of the medium, like p, the particle of p also vibrate in the f direction. And second type of waves are electromagnetic waves. The second type of waves are electromagnetic waves. So what are electromagnetic waves? The wave which do not require medium. Any wave which do not require medium for propagation are called electromagnetic waves. These waves can travel through vacuum also. For example, light, the light waves, or X-ray waves. These both are the type of the electromagnetic waves. Basically, electromagnetic wave is like we take a chamber. We take a chamber like this. This is a glass chamber. We put a vacuum at here in a hole. We vacuum pump, here is a vacuum pump is connected with it, and all the air which is inside it and all other particles are inside it or goes through the vacuum pump outside, and this in this there is nothing, there is only vacuum. What is a vacuum? Vacuum means the absence of everything, or nothing is present inside that. That is vacuum. It vacuum is basically no air, no type of gas, no air is present in that. So that is vacuum. So if we put a mobile phone in it and call on that mobile phone, the vibration, the ring of that mobile phone we cannot hear if we cannot hear outside that glass or inside also that glass, because the ring is an example, the ring which is an example of sound. The ring produces the sound, and sound is example of mechanical wave, and mechanical wave need a medium. So here is not, and in this chamber this is a vacuum, so the medium is not present here, so we cannot able to hear the ringtone of the mobile phone. And now we clear this chamber, we in this chamber nothing is in this chamber, and we put the chamber and we put the chamber in sunlight, so the light can pass through this chamber, because the light is an electromagnetic wave, and the electromagnetic waves not require medium. Any medium they can pass through vacuum. So now we come to characteristics of sound waves. Now we discuss what are the characteristics of sound waves. Frequency. What is frequency? The number of vibration per second is called frequency. So the first thing in a the first characteristics of a sound wave is they have frequency. And what is frequency? Frequency is the number of vibration, or we can say number of oscillation per second is called frequency. So like if the any object, or like this is a pendulum, let me take an example of pendulum. This is a pendulum, it oscillate like this, it oscillate 10 it complete 10 oscillation, or it vibrate 10 time in a second. So the 10 so this is 10 is the frequency of this pendulum, and this the SI unit of the frequency is hertz. And we also learned in the previous class, in the 8th class, that We cannot hear the sound or below the frequency of 20 hertz and above the frequency of 20,000 hertz. Second characteristic of the sound sound waves. The second characteristic of the sound wave is amplitude. The second characteristic of the sound wave is amplitude. What is amplitude? The maximum displacement of each particle from its mean position is called amplitude. So amplitude basically is like this is the mean position of the object. This is the mean position of the object is straight line. It is not straight, I know, but it is let we consider that it is a straight line. The maximum displacement like of an object, like firstly it goes up, then suddenly down, then up, then down, then up, then down. So the maximum displacement, like here the maximum displacement from the mean position is this and this. So the maximum displacement, this is known as its amplitude. And the SI unit of amplitude, remember that the SI unit of amplitude is meter. The amplitude is mark or amplitude is measured in meters. Third characteristic is time period. The time taken to complete one vibration is called time period. Frequency 1. So, basically time period is the time taken to complete one vibration is known as time period. So one vibration, we again take an example of the pendulum. In what time? In what time it complete an vibration? What is the vibration like? It goes there and come. It goes there. It goes in this direction and attain a height, and then goes in opposite direction and attain the same height and come to its mean position at here. Come to its mean position is known as the come to its mean position is one vibration, and what time it takes to complete this one vibration is known as time period. So like frequency 1, frequency 1 divided by time period, or we can the symbol of frequency is v is equal to 1 by t. So t is time period. So what is frequency is equal to 1 by time period. Fourth characteristic is length, wavelength. Fourth characteristic of the sound wave is wavelength. Wavelength, two nearest, the distance between two nearest or adjacent adjacent crests or troughs of a wave is known as wavelength. So what is crest and troughs? Crest is like uh, this is the mean position, the crest and toe. This is crest and the valley like this is toe. Now we come to fifth characteristic of the sound wave. Velocity of wave. What is the wave of the sound have some velocity. Or what is velocity? The simple definition is the distance traveled by a wave in 1 second is called velocity of wave, or we can say speed of the wave. The SI unit of the velocity of a wave is measured in meter per second. Is measured in the meter per second. It means that like the velocity, for example, the velocity of the sound wave approx in a room temperature in the air is 340 meter per second. Now we come to sixth characteristic of the sound wave. The sound wave have pitch. What is pitch? Pitch is a sensation, or we can say, brain interpretation of the frequency of an emitted sound and is the characters and it the and is the characteristics which distinguishes a shrill, or we can say sharp sound from a grave or flat sound. So a pitch basically is a pitch is basically a sensation or brain interpretation of the frequency of an emitted sound the pitch is basically the sensation of an emitted sound or frequency of an emitted sound, which has the characteristic to distinguish the sound has the characteristics to distinguish or differentiate between the sharp and grave, or we can say the sharp and flat sound, or we can say shrill and grave sound. Loudness. The next characteristic is loudness. Loudness. What is loudness? Loudness. It is a measure. It is a measure of the sound energy reaching the ear per second. So loudness is basically the measurement of the sound energy which is reaching to our ear per second. And now we come to next point, reflection of sound. What is reflection of sound? Reflection of sound is basically when sound waves strike a surface, they return back into the same medium. This phenomena is called reflection. So basically, if the sound waves is going in the direction of P, they strike a surface. Uh, Let me take H. They strike a surface H. So the surface they strike this surface H, and they bounce back in the same direction from the same medium. If the sound waves are coming in from the medium of air, they return back in the same medium which is air. is known as the reflection of the sound. Laws of reflection. Now we come to the seventh point, which is laws of reflection. The laws of reflection. Angle angle of incidence is equal to the angle of reflection. The same law is used for the light ray. Angle of incidence is equal to the angle of reflection. It means that if the sound is strike on this surface, the angle of incidence. Sorry, let me tell you the surface B. So the light ray or the incident ray of the sound is strike that surface on the angle of theta. Let me take theta. So it bounces back. Now it is when it bounces back, then it is a reflected ray of sound. So reflected wave of sound, and the angle of that reflection is also theta. It means let take the numbers instead of theta. Let me take that it is strike on the angle of 60 degrees. So reflect on the angle of 60 degrees. The incident wave and the reflected wave and the normal are lies in the same plane. It means that the like this is the incident ray, this is reflected ray, and the normal is between them, perpendicular between them. This is normal ray. So these all are lies on the same plane. These all are lies on the same surface, or we can say same plane. Now we come to echo, or we can say echo. Echo is a phenomena of hearing back our own sound is called echo. It means that the if we are in a room, we are in a room, and we say anything like we say hello. So the sound, the vibration of the particles, the sound is going in this direction, and it strike of anything else, anything. It can be a wall, it can be wall, it strike wall, but here is a condition that the wall should be 17 meter away from the source of the sound, and between them anything will not be come. So it's strike here. So the bounce back of the sound is over and over again. Like we say one time hello, so we hear the bounce back of the echo. The bounce back of the sound is two or more than two times. Then we say it echo. It is due to Thus, echo is due to the successive reflection. Successive is more successive reflection from the surface, from any surface, successive reflection from the surface obstacles of large size. The surface must be a large size. So now we come to our next point: relation between speed of sound, time of hearing echo, and distance of reflection of body. Different distance of reflection body. So the relation between them is, if t is the time, if t is the time at which an echo is heard, if t is the time at which the echo is heard to our ear, then the d is the distance between the source of the sound, and the d is the distance between the source of the sound and the reflection of the body. So the v is frequency. So the v is the speed of the, not here the v is used for the velocity, sorry. So v is the speed of the sound. So the total distance traveled by sound is 2d, because the sound in is goes in the in a direction like this. Let it take cover 17 meter in this direction, and it goes back, it reflects back and goes to the source of the sound. So the source of the sound is 17 meter away from that, the where the sound is reflected. So it also then also cover the 17 meter. So the distance is 17 into, sorry, 2 into 17. So the distance is traveled by the sound is 2 into 17. It means 2 times 17. So we get the speed of the sound, which is v. We get from 2d is the speed of the sound, which is v, is 2d 2d by t. Let me say that the sound travel this distance in 1 second. As for easy, we can say that the sound is travel this distance in 1 second. So the velocity of the sound is 2 into 2 into 17 by divided by 1, 2 into 17, or we can say d is distance, and d is equal to v into t. It means time velocity into time by 2. Where from the 2 come, the 2 is come from the 2d. Let we go ahead. Conditions. Now we come to the 10th point: the conditions for the formation of an echo. So now we discuss what are the conditions to form an echo. So the minimum distance, I tell you above that, the minimum about this, that the minimum distance between the source of the sound and the reflecting body is should be 17.2 2 meters, or we approximately take the 17 meters. And the second point is wavelength. Wavelength of the sound should be less than the height of the reflecting body. So what is the wavelength? The wavelength is the displacement. Wavelength is the distance between the crest and toes. So the height of that body, or of that reflecting body, should be higher than the wavelength, or the wavelength should be shorter than the height of the body or reflected body. The inner the intensity of sound should be sufficient so that it can be heard after reflecting. It means that the intensity of that sound wave should be sufficient so that we can heard after reflecting. It means that it had to be more than 20 hertz and the less than 20,000 hertz. Now we come to next point. Now we come to 11th point, which is reverberation. What is reverberation? So reverberation is pre-existence pre-existence of sound, pre-existence of sound after its production is stopped, is called reverberation. For a short reverberation is desirable in a concert hall. What is a concert hall? Where the music being played, the concerts are held, and so the short reverberation is desirable in a concert hall. We can observe the reverberation in a short reverberation in a concert hall, because it gives life to sound. The reverberation gives life to sound. Too much reverberation confuses the too much reverberation confuses the programs and so programmers, and must be reduced to reduce reverberation. So the reverberation is give life to sound. The reverberation is the main component of the sound. So the too much of the reverberation is confused to the program. Who are the programmer who perform the music on in the concert hall, and so the reverberation must be reduced. The reverberation is not if the reverberation is too much, the programmer will be confused, so it must be reduced to reduce reverberation. Range of hearing. The audible range of sound. The audible range of sound for human being extended from about 20 hertz to the 20,000 hertz. 1 hertz is equal to 1 cycle per second. So the sound of frequency below 20 hertz are called infrasonic sound or infrasonic sounds, or we can say infrasound. and the frequency higher than 20k hertz or 20,000 hertz are called ultrasonic sounds or ultrasound. So ultrasound is produced by dolphins. The ultrasound is produced by the dolphins. Here is an example is also given. So we can hear between the range of the 20 hertz and the to 20,000 hertz. It means that the we cannot hear below the 20 hertz and above the 20,000 hertz. So 13th, now we come to 13th point. Application of ultrasound. What is the application of what is ultrasound? Now we talk about ultrasound in the detail. The ultrasound is commonly used for medical diagnosis. The ultrasound is commonly used for the medical diagnosis and therapy. The ultrasound is used in the in the hospital in the medical diagnosis and for some type of therapies, and also as a chirurgical tool. It is also used in a wide variety of industrial applications and processes. It is also used in the wide variety of industrial application and processes in industry. In under industrial processes, the ultrasound is used in the various type of applications. Some creatures use ultrasound for information exchange and for detection and location of any object. So, for example, bats and porpoises are found to use ultrasound for navigation and to locate food in dark or at a place where there is inadequate light for vision. It means that the bats are use ultrasound waves for navigation, where to locate their food or navigation where there is darkness or the sunlight or any type of light is not enough to vision. So the method of search, this method of navigation or searching of food is known as echolocation. Sonar. Sonar is a tool which mean as from sound and from navigation or from ringing. And this is the full form of sonar. It means in in a sound wave which is ultrasonic are used microwaves as observed in water. In underwater, the submarine are used sonar for locate or for navigation underwater. The submarines are used sonar. These sonar are use the sound waves which are ultrasonic. It means they are ultrasonic sound waves which are used microwave or we can say which are used microwave are absorbed by water because the ultrasonic waves are used because If they use sonar in the sonar, the microwave, then the microwaves are absorbed by the waters, so they cannot help in the navigation, so they use ultrasonic waves. Sound waves are emitted by a source. Sound waves are emitted by a source. These waves travel in water with velocity v. The velocity is v, and the wave reflected by target, whatever the target, like in the submarine bottom, submarine, the bottom of the sea, the target are detected. Uses of sonar. Now we talk about the uses of the sonar. First use, the sonar system is used for detecting the presence of unseen underwater object, such as a submerged submarine, a sunken ship, a sea rock, or a hidden iceberg, and locating them accurately. The sonar is used, basically a sonar is used for the detection of the presence, which cannot be seen underwater object, such as the submerged submarine, the ships, sunken ships, or sea rocks, or the icebergs. These are some types of things which can detected by the sonar. The principle of sonar is also used in industry for detection of flaws in metal blocks or sheets without damaging them. And sonar is also used in the industry for detecting the flaws in the metal sheets, in the metal blocks or sheets. It cannot damage, or it cannot damage them, and it can detect the flaws in a metal block or sheet without damaging them. It not given damage to the block or the sheet, and it detect the flaws. Human ear. Now we talk about human ear. Human ear. It is a highly sensitive part of human body which enable us to hear a sound. We can hear with the help of our ears. It is a highly sensitive part of our body. It converts the pressure waves in air with audible frequencies into electric signals which travel to brain via the auditory nerve. It means that our ears convert the convert the pressure variation in wave with the audible wave, which are the audible to our ear, and convert them into the electronic signal, and send it them that electronic signals to our brain via or by with the path of the auditory nerve. The human ear. The human ear has been divided into three main parts. These their auditory function are as follows. So first part is outer ear. outer ear, that the outer ear is called pinna. So what is the outer ear? Which we see outside our, like, this is somewhat the shape of the outer ear of an human, like this. And this is somewhat like the shape of the outer ear of any human. So outer ear basically, see which we can see from the outside, which we can see from the outside with our eyes. We can only see from the outside that the pinna which is outside our body. We cannot see the inner parts of our ear. So the pinna, what is the work of the pinna? The pinna collects the sound from shuri surrounding. The collected sound passed through the auditory canal, and the end of the auditory canal, at the end of the auditory canal, there is a tiny membranes called the eardrum, or the tympanic membrane. When compression of the medium produces due to the vibration of the object reaches the eardrum, the pressure on outside of the membrane of the outside of the membrane increases, and forces eardrum inward. Similarly, the eardrum move outward when rarefaction reaches in this way the eardrum vibration. So basically, I will explain you with the help of diagram. So basically, this is like uh, this is the pin of our outer ear, part of our outer ear which we can see from outside. And from this auditory canal, it goes like this is the auditory canal. The vibration is goes in this canal, and here is a eardrum. At somewhere here is our eardrum. This vibration beat this eardrum, and it start vibrating with the same velocity, with the same frequency. And then that frequency goes to the middle ear. What is inside the middle ear? In the middle ear there are three small bones, like structure like this. First bone and second bone is joined like this, and the third bone, and this is the middle ear. So the vibration, here this given the vibration are amplified several times in three bones. These three bones, the first name is hammer, second is anvil, and third is stipper. In the middle ear, which act as lever, the middle ear, these three bones are act as the lever. The middle ear transmit the amplified pressure variation received from the sound waves in the to the inner ear. So these vibration is passing through the middle ear from these three bones, and goes to the inner ear. What is inside? What is inner ear? Inner ear. In inner ear, the pressure variation are turned into electrical signals by the cochlea. That is silent here by the cochlea. These electrical signals are sent to the brain via auditory nerve, and the brain interprets them as sound. So basically, this is pinna, this is pinna, and this is auditory canal. This is eardrum here. These three bones, and it goes to the like is joined to the inner ear, and this is the some like this. Uh, Here, not here. Like inner ear is like a canal, like in which the water is filled, and it has small hairs called cilia, and it convert this inner ear convert that sound waves into the electronic signal, and from here it goes through the auditory canal to the brain. So basically the inner ear is do uh, the sound waves, inner ears convert the sound waves into the electronic signals, and that electronic signals are passes through the auditory canal or auditory nerve, and goes to the brain, and the brain interpret them as sound of any object. It means that the brain read them the electronic signals, and it interpret then electronic signals are as sound. So this is all for the day. Thank you. Have a nice day. If you like my video, please subscribe to our channel and click on the bell icon for taking my all the notification. Thank you. Have a nice day. Bye bye.